Guys, welcome back. Let's pick up 11.1. Let u be the vector with initial point 2, -5, and terminal point -1, 3. That means our starting point is 2, -5, and our ending point is -1, 3. To find what that vector looks like, we can take -1 minus 2 and 3 minus -5 to get -3, 8. So this is our vector in vector form. So that is our u. And it says let v be 2i minus j. So if I'm writing this in terms of I and j, this is -3i plus 8j. And it said v is 2i minus j. Write the following vectors as combinations of I and j. Well, we just did u. -3i plus 8j. 2u minus 3v. So I've got 2 times -3i plus 8j. Got -3 times 2i minus j. That would be -6i plus 16j. This one is -6i plus 3j. Since I already distributed the negative here, I'm adding. Total, that's -12i plus 19j. Which would be the same thing as writing -12, 19 as a vector. Half u plus 5/3 w. So we've got half of -3i plus 8j. 5/3 times 2i minus j. That would be -3 halves I plus 4j. This one is 10/3 I minus 5/3 j. You think it might work out nicely, but it's not going to. This is -6 or -9/6 I. This one is 26i. When I add those together, I get 11/6 I. This is 12/3 minus 5/3, 7/3 j. So the same idea, different form. Now vectors have applications in word problems. If two forces are acting on an object, the resulting force is the vector sum of the two forces. So this is two tugboats are pushing an ocean liner as shown in the figure to the right. Each boat is exerting a force of 400 pounds. What is the resultant force on the liner? So this is a picture of what would happen. We've got force 1. It's 400 pounds, but that angle it's pushing at is the x value is 400 times the cosine of 20 degrees because it's pushing at a angle of 20 degrees. So we have 400 cosine of 20 degrees. The y value is then 400 times the sine of 20 degrees. Now for the second force, it's pushing at a -20 degree angle, so it's 400 times the cosine of -20. This is 400 times the sine of -20. Now because sine is odd, sine of -20 and sine of 20 are opposites, so when I add those two together, it's a total force. We've got 400 cosine of 20 plus 400 cosine of -20. And then here we've got 400 sine of 20 plus 400 sine of -20. Odd, so this is 0, which is, there's evidence of that by the boat moving straight to the right. And since this is even, this just becomes 800 times the cosine of 20, and you can put that in a calculator to see exactly how much that is. But that is an application of vectors relative to physics. And a lot of you took physics last semester, and you're like, well, maybe this could have been useful to understand before, but you're understanding it now, maybe. Another application, this one without a picture, is airplane and wind speed and how they interact with each other. If an airplane is traveling at a fixed altitude at a speed of 500 miles per hour at a bearing of 330, so let's talk about bearing of 330 means you go around clockwise 330 degrees. So there's only 30 degrees left. So this is 500 miles per hour. So it encounters a wind of velocity 70 miles per hour and 45 degrees east of north. So that would be the equivalent wind 45 degrees east of north, and it's 70 miles per hour. What is the actual resulting speed and direction of the plane? So you break it down into its components. 30-degree angle, this is 250 miles per hour here, and 250 root 3 miles per hour north. For the wind, 45 degrees. This will be 35 root 2 and 35 root 2. So my force 1 is the plane. It would be a vector of, in the x direction, that would be negative 250. The y direction, it's 250 root 3. F2 is, they're both 35 root 2. And so my resulting force, plane, is negative 250 plus 35 root 2, and 250 root 3 plus 35 root 2. Now, this tells me kind of that's the direction. It's not really the speed, because in order to find the speed, I would need the magnitude of this thing. To find the magnitude of this thing, I would need to do distance formula. So that would be negative 250 plus 35 root 2 squared plus 250 root 3 plus 35 root 2 squared, and take the square root of it to get speed. Now you can put this in the calculator or Google. I'll get approximations for those two numbers before. So let's look. What is negative 250 plus 35 square roots of 2? That's approximately the square root of, looks like negative 200.5 squared. Now let's do 250 square root of 3 plus 35 square roots of 2 plus 482.5 roughly squared. You can square both of those. This is the square root of 263,456.5. And that is 513.28 miles per hour. So what does that mean? Well, the wind is throwing it off in its direction. The plane was originally going 500, so this is actually working with it speed-wise. We don't really know where it's wanting to go, but that's at least something that's helping. And that's all for 11.1.